It's an exciting time to be a researcher in the Memory and Aging Center because we're closer than ever to actually halting the progression of dementia with clinical trials for anti amyloid and anti tau drugs. But what are you, an aspiring postdoc, to do when the condition you study is about to be cured? There's a hitch. These drugs halt the disease, not reverse it. That means if we can catch a disease earlier, we could prevent unnecessary damage. For many frontotemporal lobar degeneration spectrum diseases, speech is one of the earliest signs that something is wrong, and I think the key to early diagnosis. I'm envisioning an automated tool that detects subtle changes in speech for early diagnosis. I'm actually collaborating on one of these tools right now with Berkeley, but I think there's a deeper issue I need to tackle before I'm satisfied with this tool's performance. As much as it would bring me joy as a speech pathologist, 3 minutes just isn't enough to give a crash course on motor speech disorders. The core of the issue that I want to solve is that motor speech disorders weren't initially described with FTLD in mind. The existing labels that speech pathologists use for motor speech impairments don't harmoniously fit the patients we see at the Memory and Aging Center. That's because these tools were based on other conditions that affect the brain in different ways than FTLD does. To build a tool that can detect early changes to speech, we first had to determine what those changes actually look like in the different FTLD spectrum syndromes. My plan for doing this is to leverage the massive dataset of speech testing data in the Memory and Aging Center. I have 25 years of speech testing data to work with. I've collaborated with other speech pathologists in the Memory and Aging Center to come up with a list of 50 traits that encompass the entire range of problems one could have with motor speech, regardless of any existing taxonomy to describe those problems. Right now, I'm going through this massive data set and marking which patients have which speech features. Once that's done, I am going to use a psychometric framework called item response theory to uncover data-driven clusters of speech features in the data. I can then map these clusters to patterns of atrophy in the brain. This will allow me to link sets of motor speech problems to the atrophy patterns of specific diseases in a way that was designed from the ground up for use in FTLD, rather than for some other condition that fits the existing motor speech hierarchy. Then, it's simply a matter of taking those patterns of motor speech features back to Berkeley to develop tools for early diagnosis based on audio samples. I may not be making the drugs of the future that are going to cure dementia, but I'm building the tools that will help us minimize the harm it can do.